So, limits and continuity. Uh, can you explain what is your idea about limit? Okay, and what about continuity? Uh, okay, basically, we use limits for checking continuity of a graph, right? Right? Okay. Continuity of a function or graph. Uh, that means here we can check whether the graph or function is continuous in a certain uh, point or range also. Okay, let me start with limits. If we want to start limits, then at first we have to uh, know what is tangent line or what is secant line, right? Both of them are related to limits. Okay, in this chapter, that is chapter 2 from the Thomas calculus. Okay, well, here limit and continuity, that is basically on a single variable. Uh, at first, we need to know the rates of change tangents to curve here. Uh, what is a rate of change? Okay, here velocity, yeah, it can be velocity also. Okay, look at this graph. Look at this graph. Here, blue line is the graph of y equals to f of x. Okay, then there are 2 points on this graph. First one is P and second one is Q. So if we add these 2 points directly and we have a straight line joining these 2 points, and this line is called second line. Okay, okay. But what about a tangent line? That is okay. That means basically if we draw a line which touches the graph, basically. For example, that is the best example for a tangent line is if we draw a circle, we know that on a point of a circle, we can draw only one tangent line, right? So if we see here, okay, here if this is the point and we draw a line which touches the circle on the point, then we can say this is tangent line. Okay. So similarly, over this graph, in a point, if we draw a line, then we can say this line is a tangent line. Okay. Now, here we have P, and the coordinates of P is x1, f of x1. Okay. So that means starting, if we start from here, then the distance that is x1, and here this one is f of x1. Okay, okay. Then we have another point on the graph, that is q, and the coordinates of q is x2, f of x2. So that is from here x2, the value of x2 is this, and then f of x2, that is basically up to this, that is f of x2. Okay. Now if we move from P to Q, okay, along with this graph, then basically what are the changes here? There are two type of changes, right? First one is horizontal, second one is vertical. Okay. Now if we consider horizontal changes, then basically to move from P to Q, we have here the distance changes, the value of the uh, change here, that will be x2 minus x1, right? Okay, so if we consider this one as del x, so value of del x equals to x2 minus x1. And now if we consider the vertical distance or vertical change, then what can we say here? This one is f of x1. So here from up to q to x-axis, that is f of x2. So what are the changes here? What are the changes here? Vertically. Okay. Notice, notice here. What is the total change here? Total change. That means basically, if we consider the movement first, and what are the coordinates of q? That is x2, f2, right? F of x2. So that means uh, this value, this value is the f2, right? This one. And here, this one is x1, right? F of x1. So since this line is parallel to x-axis, so this distance will be also f of x1, x1, x1. So what is the change here? If we subtract uh, from f of x2 to f of x1. Basically, what is the change here? This is the change. Okay, this is the change. So how can we find this value? F of x2 minus f of x1. Okay, okay. So if we consider, since this is vertical change, right? Okay, so we can say here delta y equals to f of x2 minus f of x1. Okay, so now what is the rate of change? That means, okay, for these horizontal changes, we have vertical change this, right? Right? So for rate of change, that means uh, unitary change. That means uh, that means for delta x changes, we have delta y change, right? For one unit change, we have delta y by delta x, right? So that is the rate of change. Now we can write here delta y by delta x equals to f of x2 minus f of x1 divided by x2 minus x1. Okay, we can also simplify this as if we consider this horizontal change is uh, very small. That means if we consider x2 minus x1 as h, so we can write h in place of x2 minus x1 and over f of x2 minus f of x1. Okay, that is the basically rate of change del x. Okay, now if we move on, the definition of limits basically. Uh, okay, I will move on that later. At first, this is the rate of change basically, my average rate of change, and we have this right. Uh, So the average rate of change of y equals to f of x with respect to x over the interval x1, x2 is this, this one. Okay. Okay. Now, so based on this, we have some uh, example just to understand the topics here. Uh, Find the average rate of change f of x equals to x squared plus 1 over 1 3 and over 2 and 2 plus h. So how can we find that? We have here the interval 1 3. So uh, a rate of change, that is del y by del x equals to f of x2. Right? F of x2 minus f of x1 divided by x2 minus x1. So if we put the values here, then we have here this. Okay, and for the interval 2 comma 2 plus h. So this one is x1 and we can consider this one as x2, and then delta y by delta x, that is f of x2 minus f of x1, and then x2 minus x1. So we will have h. Okay, then if we put the values here, then we have here this. So as here observation, that is if h tends to 0, what does it mean? That means the value of h, if approaches to 0, that means the change is very little. If we move from P to Q, okay, if P approaches to Q, then H approaches to 0. That is, H tends to 0. Okay, then here H, if we put 0, then the value approaches to 4. If H tends to 0 here, so the average rate approaches 4. That is the instantaneous rate at x equals to 2. Uh, we have here, we already know what is now, what is second line and what is tangent line. Okay, so from here, this one is very important for us, using limit scope m tangent equals to limit h tends to 0 f of c plus h minus f of c by h. Okay. Before that, I will explain here. That is, now, okay, okay. Now, if we if I explain limit, that is, if first consider a function that is f of x equals to just like x squared negative 1 by x negative 1. Okay, and if you are asked to find what will be the value of f of 1, so how can we find that? We have to put, or we have to replace x by 1, right? Okay, now look at here. If we replace x by 1, then what happens here? F of 1 equals to 1 square minus 1 by 1 minus 1. So we have here 1 minus 1 by 0, that is 0 by 0, right? So what happens now? Undefined or indeterminate form. So we can find the value of f of 1 for this function, right? Okay. So now if we want to check the characteristics of this function, that means when x, the value of x moves to 1, then what happens for x f of x? There is no value. But for exact x equals to 1, f of x has no value, right? But we can check what happens when x value of x approaches to 1. We can check it. We can check it. How? That is, uh, okay. Take a table of with two columns. First one is x, and second one is f of x. Okay. Now, um, and we can also draw a number line with 1, and here positive infinity, and then negative infinity. So that means x approaches to 1. That means x tends to 1. So here value of x uh, can be approaches from two sides, right? First one is from right side, it can approaches to 1, and second one is from left side, the value of x can approaches to 1. Okay, now if we put here 10 or 100, here negative 10, negative 100. Okay, now if we put here 100, then what will be the value of f of x? That means here, if we use calculator, or here 100 square minus 1, 100 minus 1, so we will have here 9 over 999 by 9 divided by 9. So we have here 1 1 1 1. Now if we put 10 here, then we will have 10 square, that is 100 minus 1, that is 99 by 9, so 1 1. Okay, now if we come closer to 1, that is 0.1. So 0.1, if we put 0.1, then we will have 0.1 square and minus 1. So it is minus 0.11. Okay, okay. No, it will be just we are calculating here the values. Those are right to one. Okay, so right to one, it will be 1.1, 1.01, right? Okay, so if we put here 1.1 here, then what we have from f of x, that is 1.1 squared minus 1 by 1.1 minus 1. Okay, so what is the value of this? That is 0 or 1.1, that is 1.21 minus 1. So we have here 0.21 and then here 0.1, right? So if we divide by 0.1, then we have here 2.1. So we see here basically for 1.1, for 1.1 we have here 2.1. Okay, now if we move from left to right, okay, if we approach to 1 from left side, then here negative 100, and then for negative 10, and then for negative 0.9. So we will see here what happens for negative 100, that is that will be here negative 100. Okay, negative 100. So we have here negative 99. Okay, and similarly, if we approach up to 0.9, it will be 1.99, just like this. So what can we see here? That means if we approach to 1 from the right side to 1, then the value uh, moves or approaches to 2. Okay, and similarly for from left side, if we approach to 1, then the value of f of x similarly approaches to 2. So from here we can make a decision that if we approaches to, for this function f of x equals to x square negative 1 by x minus 1, and if x approaches to 1, then f of x approaches to 2. Okay, so this needs a huge explanation, right? But we can easily explain this using limits. That basically that is the use of limit. So we can write this using limit as limit x tends to 1 f of x equals to 2. That means that means while x tends to 1, then the value of f of x tends to 2. Is it clear now? Okay. We can or simplify this calculation also by simplifying the function f of x. That means here we are given f of x. We are given here f of x equals to x squared negative 1 by x negative 1. So we can rewrite this one as x plus 1 times x minus 1, right? Okay, then x minus 1. So we can cancel out x minus 1 by x minus 1, then we will have x plus 1. Okay, now if we put here, if we put value of x here as x tends to 1, so f of x equals to x plus 1. That means 1 plus 1, so it will be 2. Okay. Okay. Basically, that is the use of limit. While you can't find the exact value of a function in a certain point for x, certain value for x, then we can easily determine, or you can easily find the approaching value of f of x using limits. Basically, this is the use of limit. And then using limit, we can verify or check whether a given function is continuous or not uh, for a certain range, or even for a certain point. Sorry. Yeah, right, right, right. Now, there are two types of limit. That is, two types, not basically two types. There, here we have. Oh, sorry. Okay. Now here we calculated, or we just check the values of x, that uh, value of x approaches from two sides, from right side and from left side. Okay. So if we calculate the only right side, then it calls right hand limit. And we indicate this as limit x tends to 1 plus of f of x. This is the right hand limit. Okay, if we consider the values of x from left side, then it called left hand limit. Then left hand limit, we write this, the notation of the left hand limit is limit x tends to 1 negative, just negative sign on top of 1. That is the f of x. Okay. And we have functional value f v, that is called functional value. What does it mean? That means at exactly f x equals to 1, that means f of 1 we have here 2, right? After calculating some calculation, after some calculation, we have f of 1 equals to 2. So now, if we get the value of left hand limit, right hand limit, and functional value, all are equal. If all are equal, then we can say the function is differentiable at a certain point. But if the left hand limit and right hand limit are equal, then we can say the function is continuous at that point. Okay. Okay. Now we will move on some calculation uh, on a limit. Here, basically, there is a definition of limit that is called informal definition, which I have already discussed. And for x tends to c, if the value of f of x is L, then L is called the limiting value of f of x. L is the limiting value of f of x for x tends to c. That means if x approaches to c, then value of f of x will be L. Okay. Okay. Uh, so here is an example. Find limit x tends to 1 x square minus 1 by x minus 1, as I have discussed about this. So if we put directly, or if we replace x directly by 1, then we have here undefined 0 by 0. So for x not equals to 1, what happens here? X square minus 1 by x minus 1, that is x plus 1 here. So if we put 1, as x tends to 1, then x plus 1 tends to 2. So the limit is 2. Okay. Here, some observations. The limit doesn't depend on f of c, where c is a constant term. C is a constant term. If c is a constant term, then the limit doesn't depend on f of c. Okay. The function need not to be defined as c, because the limiting value will be that value of f of x. There will be no change. That means limit doesn't depend on f of c. And we consider x approaching c from both sides, which I have already discussed. Okay. So another one, arbitrarily close. This is the important word which is used in limit. That means as close as we want. Okay. Now, limit examples for some basic functions. Here, first one, if f of x, if f of x equals to k, where k is constant, then for any c, a limit x tends to c of k. So there is no x here, right? So this limit doesn't depend on c. So the value of the limit will be k only. Okay, and another one, that is identity function. This one is for constant function. Okay, and identity function for that is, if f of x equals to x, then for c the result will be the c. Is it clear? Check another example. Okay, that is, if we are given here, if we are given here f of x equals to x, that is, uh, input is the output, that is called identity function. If you just use here input 1, then you'll get the output 1. If you input 2, then you'll get the output 2. That is the identity function. Okay, now for this type of limit, if limit x tends to, if you go for 2, okay, and f of x, then what will happen here? Limit x tends to 2, so value of f of x, that is 2, right? Sorry, x f of x equals x. So now replace x by 2, so that will be the 2. So it means we have here 2, so the limiting value is also 2. That is the example of this. So we have here c, so limiting value is c, since f of x is an identity function. Okay, now consider another function at x equals to 1. So what happens here? F of x, that is, we are asked to find the limit x tends to 1 of f of x. So what happens here, if f of x equals to this, we already calculated this, the limiting value is 2. Okay, and now for h of x equals to x plus 1, then what happens here? H is given as x plus 1, so that means limit x tends to 1 h of x. So limit x tends to 1 h of x, value of h of x is x plus 1. So we will have 1 plus 1, 2. That means the limit is 2. Okay. Yeah, what we did before, that is same. I'm basically repeating same example here for better understanding. So if we can relate all of these terms, then we can easily understood the what is happening here. Okay. Now there are some laws. Basically, we use this for calculating limits by knowing or unknowing, uh, but we use this here. Uh, okay, let me present another one. Here is the basically as we discussed for function f of x equals to x squared negative 1 by x minus 1. So we have here limiting value of f of 1, right? That means x tends to 1, we have limiting value f of x as 2. So, but for 1, exact 1, we have the function is undefined, right? That means we will not get exactly 2 when x is 1. That means there is the function will be broken. The function is broken here at x equals to 1. That is the visualization of this function. That means if we calculate, if we do some calculation here, f of x, then we have here x plus 1. So we can write y equals to x plus 1. Now, this is the graph, this is the equation of a straight line. But for every value on this line will not be satisfied for x equals to 1. Okay. And here are these laws. So limit x tends to 1, f of x plus minus g of x. That means if we are given two functions as sum or difference, we can rewrite this separately. Okay. And here is constant multiple law. That means if we are given a constant multiplied with the function, then we can multiply the limit with the constant. That means we can put limit just before function. Similarly, here product law, we have if we are given two functions as a product, okay, then we can rewrite. Okay, we can rewrite this as just like this. That means we can take limit on both the functions. Okay, and quotient law similar, and power law. If we are given here f of x whole to the power n, then we can write limit f of x tends to limit x tends to a f of x whole to the power n. We have to use this in some cases. Similarly, for root law, okay, we can put limit under the root with the function. Okay. Now, executing finite limits for algebraic strategies, and there are some calculations here. First one, we have here three strategies. First one, rationalizing. Rationalizing, that means here, if we are given some limits with square root, we have here root over t squared plus 9, then minus 3. So in this, to calculate this type of limiting problem, then we have to multiply denominator and numerator by the conjugate of this term. Okay, that means we have here root over t squared plus 9 minus 3. So we have to multiply numerator and denominator both by root over t squared plus 9 plus 3. Here, so we have to multiply this by this. That means uh, Okay, here then we will have, okay, we if we do some calculation here, then that means multiplied by, we have to multiply by root over t squared plus 9 plus 3, and then root over t squared plus 9 plus 3. Okay, then we have here, if we consider this one as a, if we consider this one as a and this one as b, then we have here a minus b times a plus b. So it will be a square plus b, sorry, a square minus b square, right? So a square, that means root over this square. So square root and square will be cancelled. So we will have t square plus 9, then minus 3 square, that is 9. Then we can cancel out plus 9 minus 9, and then t square by t square. Now we can easily put the value of t equals to 0 here. Then if we put t0 here, then we will have here root over 0 plus 9, that means 9. So if we take square root of 9, then we'll have 3. So 3 plus 3, that is 6. So 1 by 6. The limiting value of this function is 1 by 6. Okay. And here another one, that is factorizing. We are given here x squared plus 5x plus 6. So we have to factorize this. So if we factorize this, then we have here x plus 2 times x plus 3. That means here x plus 2 and x plus 3 by x plus 2. So we can cancel out x plus 2. Then will remain here only x plus 3. So limit x tends to negative 2, x plus 3. Now if we put x equals to negative 3, then we have here 1. So 1 is the limiting value. Okay. And here expanding, another one, that is expanding, we have here 3 plus h all square. So we have to expand this. We can expand this using binomial expansion or even applying the formula directly. Okay. Then after simplifying, we will have the limiting value. And, and based on this types, we have here some uh, problems here. Okay, we have 6 problems here. I think you can now solve it. First one, for to solve this one, what method we have to follow? Factorize. Okay, okay, good. Then for second one, number 2, expand it. Okay, good. Then number here, this one, number 4, we have two fours here. Both. No, we have to factorize both denominator and numerator. Here it is. Yeah. 3 square. Right. Okay. Okay. And then number 3. Oh, they're same. Sorry. So they're same. Yeah. And number 4, this one, next one. So this should be 3, this one 4. Okay. Yeah, right, right. That will be x cube plus 2 cube, right? So x plus 2 and then x square negative 2x then plus 4. Right. And number 5, conjugate, right? Conjugate. We have to multiply numerator and denominator both by the conjugate of root over 1 plus t plus root over 1 minus t. Okay. Then next type, that is limit at infinity. Are you familiar with this? Yeah. That here x tends to infinity. So what happens when x approaches to infinity? What happens to this function? Then to calculate this, we have to, there are three types here. Okay, first one, we have here maximum power of the variable, that is maximum power of x is 2, right? And here also maximum power of x is 2. So we have to divide all terms by the highest power of x in the denominator, also in numerator. So if we divide 3x squared by x squared, this by x squared, this by x squared, this one also by x squared, divide this one by x squared, divide this one by x squared. So what happens here? 3. We will have 3 here, okay? 3. Then negative x by x squared, that is 1 by x. Okay, and then negative 2 by x squared, here negative 2 by x squared. And in denominator, we have here 5x squared by x squared, so we will have 5 only. And then plus 4x by x squared, and then plus 1 by x squared. We basically used here the concept something divide by infinity. What is the value? No? Okay, let us check it. Okay, visualize this. If we divide 1 by 1, then what happens here? 1, right? Okay, again, if we 1 divide by 10, so what happens here? 0 0.1, 1. Sure. Okay, now If we divide 1 by 1000, then what happens? 0.001, right? So what is happening here? Smaller and smaller. So now, if uh, 1 divided by, that is a huge number. So what will happen here? Very close to zero. Exactly. Exactly. So that is happening here. So if we divide something by infinity, then the result becomes very close to zero. So here now we have x tends to infinity. So if we put infinity here, infinity, infinity square means infinity, right? So it will become infinity only. And here infinity, here also infinity. So, so this term becomes zero. This one also becomes zero. This one also becomes zero. This one also becomes zero. So what remains here? 3 and 5. So the limiting value is 3 by 5. Okay. And then radical fractions, similar. If we divide both by x, okay. If we divide this one by x, this one by x, then what happens here? So it will 3 minus 5 by x, okay. 3 minus 5 by x, this. And since x is outside the square root, right? So if we take it inside the square root, so x will become x square. Okay. Okay. So here root over 2x square by x square plus 1 by x square. It will be the numerator. So x square, it will be cancelled out. So we will have only root over 2 plus 1 by x square. 2 plus 1 by x square. Now put in place of x infinity, then what will we get here? This one will be the infinity, this one will be the infinity. So 5 by infinity, that will become 0. 1 by infinity, that will become 0. So we'll have here root over 2 plus 0, that means root over 2 divided by 3. So the result is this. Okay. Now what will happen for third one? Conjugate, right? Exactly. We have to multiply the term, that means numerator and denominator both by the conjugate of the of this term. Here we have root over x square plus 1 minus x, so we have to multiply by root over x square plus 1 plus x. Okay, then you have to calculate this. Okay, after calculating, if you put infinity here, Then I think this will be the infinity, so in total value will become infinity. So something divided by infinity that will approach to zero. Okay. So we basically, I have here discussed two types of limit. Okay. First one, first one is this. These are the basic calculation of limit, and second one is evaluating infinite limits. Okay. I will give you some homework based on these two type. Okay. Yeah, it will. I will give it in Google Classroom. Okay. So you will upload also in Google Classroom. Then I can easily evaluate this and I can give you the feedback. Okay. 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 So that's all for today. Okay. Thank you. Bye. Bye. Have a